Okay, you guys, I'm going to do a quick lesson on the exponent rules. And so obviously pause as you need to, work some problems if you need to. This might help you when you're doing your homework for the next and studying for your test over this. Okay, so the first thing is when we're adding and subtracting monomials. Basically, we're going to combine your like terms. You don't change your common variables or your exponents. So this is basically what we talked about at the beginning of the year, or in the middle of the year, when we were talking about combining like terms. We're looking at the last name. Remember how we said that if they have the last name is the same, then we can combine the numbers. So in this case, we can take, we've got x squared times y, x squared times y. Those are both the same last name. So in this situation, we can combine those. This is telling us to subtract. So we're going to do 9 minus 10 is -1. The last name then stays the same, x squared y. Okay? This is simply combining your like terms. This is only when you're adding and subtracting. Make sure that you are adding and subtracting if you're keeping the x and the y the same. I'm going to scooch in on this a little bit. So there you have that. Now, if you were going to subtract 6w from 8w, you're subtracting this number from 8w. So the 8w actually goes first. Then minus 6w, we have the same last name, w, so we're going to take 6 minus 8, or I'm sorry, 6 minus 8, and we're going to get 2w. And there is our answer. This is just more of a wording situation that you have to be cognizant of the fact that you're subtracting this number from the 8w. Okay, moving on. So now we've got the product rule. And the product rule states this is happening when you are multiplying. And when you multiply, you add your exponents. Okay, so what that means is that if we were multiplying x to the a times x to the b, now notice both of these have the same base. This only works when you have the same base, meaning this has to be the same. We don't do this if they are different. So if we're multiplying x to the a times x to b, we would get x to the a plus b. And as an example of that, if I had 2 to the third power times 2 to the second power, that would be, I've got the same base. My base is 2 in each. 2, 3 plus 2, which would equal 2 to the fifth power. So one of the ways that we talked about that looking like was is saying 2 to the third power is 2 times 2 times 2. 2 to the second power is 2 times 2. And you can see 1, 2, 3, 4, 5. I have 5 2's. So there's the visual for that. Okay? So if I had h to the second, h to the sixth, I would add 2 plus 6 to get h to the eighth. Same here, except now I've got to just look at each individual base differently. I've got numbers that I'm multiplying. I multiply those numbers. I'm not adding them. The adding only happens with the exponents. I'm still multiplying. That's what this dot is. So I'm still multiplying. negative 2 times 7 is going to give me negative 14. A squared times a to the third. I'm looking at the a's because these have the same base. A squared times a to the third. I'm going to add those exponents and get a to the fifth. Then if I've got b times b, both of those, neither one of them have an exponent written, so the automatic exponent is 1. So we're adding 1 plus 1, and that's going to give me b squared. Make sure you multiply, and then you're adding your exponents. The product rule only applies to your exponents. Okay, for the next one, the power rule. The power rule is when you are raising to exponent. And in this case, you're going to multiply the exponents. All right, so we're going to multiply the exponents. We've got this situation, x to the a times b. All right, so for an example, if I have 2 to the fourth power raised to the second power, I'm going to multiply those. So it's going to be 2 to the 4 times 2 power, which is 2 to the 8th power. And the visual for that is I basically am saying I got 2 to the 4th power twice multiplied by itself. And this is basically, I don't know if I'm going to be able to fit all these little 2's in here. I'm going to come down here. 2 4 times 2 4 times again. And when I look at all that, 1, 2, 3, 4, 5, 6, 7, 8, I'm multiplying 2 by itself 8 times. That's how you get that answer. Okay. So when you're using the power rule, you're raising it, you're multiplying it. So in this situation over here, 2 squared raised to the third power, that's going to be 2 times 3x to the 6th. Then here, you need to make sure this 2 gets distributed to every term in the parentheses. And we'll work some of those problems. So we've got, this would be the same as negative 2 squared, then m 5 times 2 times m to the third. That's a little bit convoluted. I don't really like to do it that way because that looks so big, but just to show you how this 2 gets distributed to both. Negative 2 times itself, negative 2 times negative 2 is going to give me positive 4. So I get 4m to the 10th times m to the third. Now I'm not using the product rule or the power rule anymore. I'm using the product rule because I've got the same base here and I've got exponents. So when I go to simplify that, I'm going to have it be 4m to the 13. You can see that. That's 4m to the 10th times m to the third, 4m to the 13th. Okay? All right. Now, the quotient rule, now we are dividing. This is when we are dividing. Okay? And when you divide, you subtract the exponents, which makes sense considering when you multiply, you add the exponents. when you divide, you subtract the exponents. So this is the same thing as, and of course, again, we have to have the same base. X, A, the numerator goes first, minus B, the denominator. So kind of going back up to our example, if we had 2 to the 4th divided by 2 to the 2nd, that's basically the same thing as 4 minus 2, which equals 2 squared. You subtract those exponents, okay? Now, we're going to get into negative exponents right here, because if I were to have 2 to the 5th divided by 2 to the 8th, that would be 5 minus 8. That's going to give me 2 to the negative 3. And we're going to learn right here that that's not a negative number, it's actually the reciprocal. And we'll talk about that. So I need a new piece of paper because the visual for this is a little bit extensive. So if I have 2 to the 4th over 2 squared, that's the same as 2 times 2 times 2 times 2 divided by 2 times 2. Now we know that 2 divided by 2 is going to give me 1. So I can cancel those out. 2 divided by 2 is going to also give me 1. So I can cancel those out. I am left with 2 squared. But if in this other example, I have 2 to the 5th divided by 2 to the 8th, that's going to be 2 times 2 times 2 times 2 times 2. Oh goodness, why did I pick 8? All right, I think that's 8. 1, 2, 3, 4, 5, 6, 7, 8. Then when I start canceling them out, they're going to battle, right? And who's going to be left? These 3 2's on the bottom. What goes up on the top? There's nothing on the top. Well, we know we've canceled all these out and they have equaled 1. So the 1 is still left on the top. This is actually going to be 1 over 2 to the 3rd power. And we look up here and we had here 2 to the negative 3 power. And we realize that this negative 3 does not mean a negative number. It actually means the reciprocal, that you need to flip it to the other side. And we'll talk about that a little bit more, about how this guy is a traitor. And if he's negative, then that means he's on the wrong side of the line, and he needs to be flipped over to the other side of the line. Okay, so we've got here 27 divided by 42. I'm still dividing these. I'm not subtracting these. I'm still dividing these. We are dividing. The only thing we subtract are the exponents. So when I divide 27 by 42, those are not equally divisible, so I have to reduce those fractions. And so when I reduce, I can say 3 divides into 27 9 times. 3 goes into 42 14 times. Now I've got an x to the 5th and an x on the bottom. They're going to war. Only one side can win. You can only have your variable on either the numerator or in the denominator, not both. This town's not big enough for all of those x's. It has to be on one or the other. So when I look at these, if they go to war and battle it out, the one x is going to kill off the other x, and I'm going to be left with x to the 4th on the top. And that is my final answer. All right. I'm going to show you on this one, I'm going to change this number to A4. So when I have my quotient, or I've got to use my power rule here, I'm multiplying these, so I get y squared raised to the 4th power. I multiply 2 times 4, and I get y to the 8th divided by y to the 4th. In this case, they're going to go to battle. It's going to be a 1-to-1 ratio, and I'm going to be left with 4 y's in the numerator. And as we know, when you have just y's in the numerator, then it's over 1, right? If I had to cancel that out, I'd have 1 in the bottom, and we don't write that 1 because it's implied. Moving on, the negative exponent rule. Get that over there. The negative exponent rule. So we've got, that might be a little better. We've got x to the negative a, and we know that x to the negative a is going to be 1 over x. We talked about that a little bit, to the a power. And notice, this guy is a traitor. He has a negative. He needs to go to the other side. And when I flip him to the other side, he's positive again. He's where he belongs. All right? So the same thing would happen is if I had x to the negative 3, that would be 1 over x to the 3. The 3 becomes positive. If I had, for an example, 1 over x to the negative 5. Now he needs to be flipped. He's on the wrong side of that border. He's on the wrong side. We need to flip him to the numerator, and when he goes up to the numerator, he becomes positive. Okay? So x to the 5th, when it's in the, no matter where it is, if it's a negative exponent, it needs to be flipped to the other side. Okay, they're traitors. They need to go back to their people. So here, this negative 5 is just the same negative 5 as we've known since we were 5 years old, or probably in elementary, not 5 years old. That's a little too young. Same negative 5. We do not touch this negative. This is the same negative that we've known since we've been knowing negative numbers. It's the negative exponent that we're learning about. This is what causes it to be flipped. Don't flip your 5. The 5 stays. So we've got negative 5 is still in the numerator, just like it is here. The x squared, though, goes in the denominator, and the 2 becomes positive. So this would be your answer. And typically, we only want to have solve where only positive exponents. So in your answer, you should only have positive exponents. All right, so here we've got this situation. 4 divided by 8 is 1/2. K squared divided by k to the 5th. They duke it out. The bigger k is going to win. And there's going to be 3 left over. So there is my answer. Okay. Lastly, you've got your 0 exponent rule. Any number or variable or anything raised to the 0 power is 1, period. So I don't care what this is. Whatever is raised to the 0 power equals 1. That's all there is to it. It does not matter. 362 raised to the 0 power 1. X squared y cubed over z to the 7th, all raised to the 0 power, equals 1. It does not matter. Anything raised to the 0 power is going to be 1. So now we've got 7x to the 0 power. The 7 isn't raised to the 0 power, just the x is raised to the 0 power. So that's going to be 7 times, because since there's no symbol in between them, we're always multiplying. So 7 times x to the 0 power, which is 1, is going to equal 7. Now we've got this power rule, w to the 4th raised to the 2nd power. So we are going to multiply these two based on our power rule right here. X to the a raised to the b power. You multiply them. So this is going to be w to the 8th over w to the 8th. Now we know there's two ways to look at this. We can use our quotient rule, where when we divide, we subtract. So that can equal w8 minus 8, which equals w to the 0 power. 8 minus 8 is 0, which equals 1. Or another way to look at this is to say any number divided by itself is always going to equal 1. If you have one number divided by the exact same, no matter what it is, it's going to equal 1. And it's not 1w, it's not anything other than 1. So anytime, and the sooner you can understand this concept, I'll tell you, we'll go over that many, many, many times. This is always 1. Whenever you're multiplying or dividing the same over the same, it's always going to be 1. All right, hopefully that'll help.